This
Recording.
conference will now be recorded.
So hi everyone. Good morning and good afternoon. Happy New Year for all who joined us today. What we plan to do today is this New Year's time is to recap of all the progress and the good and accomplishments that we have had with TAP in this recent year. So far we had 12 meetings and a few side work sessions and some demo days. These are all going to be captured here, and really the purpose is for us to line up the challenges that we still have and what we plan to tackle in 21. So Si Ahmed has joined us. Let's go right in. The purpose of today is really to get more conversation going, so the team members to sound their voice and shape the next year. Less about us presenting. Ahmed, would you like to take over the next couple of slides? We can
You're
hear
on
you.
mute, Ahmed.
Okay, great. So sorry I was a little bit late. First of all, like Happy New Year, everyone. We just wanted to basically have a recap of like what we had last year and where we are today, and basically what we're looking forward for 2021. So first, like we wanted to just quickly recap on like why did we start TAP, and mainly as we have it like written here, like we want to influence and align the efforts like across industry when it comes to synchronous distributed systems. So as most of you know, of course, we have like NTP, like one of the oldest long-lasting protocols from the 80s that is being serving whatever it's needed, like was intended for, and so on. However, there was need for more precision time and so on, and that's why PTP basically was introduced in 2002. And then basically how we can now take advantage of this capability of like this precision time, how the same way like it was done in telecom, in datacom in our industry. And you cannot do these things from experience, like looking from like I don't know like other projects. You cannot do these things just one company or something. Like it needs an industry-wide effort, a lot of like reshaping, and everything comes like when you have a lot of voices, a lot of opinions on how you basically move these things forward. And then also we wanted to have a platform where we can have like these collaborations, which they basically go across like interdisciplinary things on these efforts, and just ease out like these things in a better way, like as like more people come in, more opinions, more resources, and so on. And then there again, currently there are available tools, like for example PTP4L is a great Linux implementation for the IEEE 1588 standard. However, again, it's been more of an open source volunteer based project like that. When you want to take it to scale, it definitely needs, we always say like it needs more love. So we need to have more resources, more people like looking at it a little bit more serious, more like QA, more like, I don't know, how can you break it? What are the limits and so on? Like we've been doing some tests, and we noticed a lot of limitations, and we're basically trying to figure out solutions for them. And we really like to have avoid basically parallel things. Like I love to have, let's say, a fork of, let's say, the project from GitHub on the OCP GitHub, and the moment we get everything done and so on, basically push it back in the trunk. And I don't want to have, like, let's say, parallel things there that will just confuse people. Which one should I take and go forward? And most importantly, we want to share, learn, network, and have fun, basically. And like, it's very interesting. I met so many people here, and I consider them like as best friends now. And I never met them in real. And that's like the beauty of like what internet and everything is bringing. Probably this is the only positive side of like this pandemic, I can see that it basically enabled these things to us. So we are sort of like defying distance, you know. Okay, let's go next slide. These are highlights from 2020. We had, as Alad mentioned, like we had 12 biweekly meetings, and we started with like kickoffs, and we tried to basically look at like this. I think this presentation was from Gary about like oscillators and so on, and then we basically went for some practical use of like basically synchronous systems and like clocks basically across the system. We had the meeting about TSNs. What happened? Oh. And yeah, we had this timekeeping and synchronization meeting. I think this one was from Gary, I'm not sure. And then we introduced basically the work streams. And so far we had basically these meetings that they were focused, let's say, on the work streams. As you know, like we have right now currently 3 work streams, established work streams. One of them is the open source Grandmaster. So the time card is basically the heart of open source Grandmaster. We had like the proposal meeting, and then we walked through like basically what was going on and what we have and so on. I'll go more in details for like another slide that we have for this. Then we had the second work stream, which is the DC profile, led by Michelle. The first one is led by, again, the Open Grandmaster is led by Oleg, and the second one is led by Michelle. And again, Michelle went through like some initial draft, and again, we'll get to that slide, and probably I will just have him chime in. And the third one is basically overall the software stack of what we have like to enable, again, PTP. Again, I want to make sure this is Time Appliances project, is not PTP project. So PTP is right now, we're going further, but we are very agnostic and we're open to other things. And as I go forward, I will show you, like, we are always looking for alternatives. We're looking for everything that can basically serve it. And we had the last meeting, which was about chip-scaled atomic clocks. And that one basically was in focus for our 4th work stream, which basically is about oscillators. And as I go forward, like I'll talk about it more. And this one we're hoping, sorry, the previous one, again, the software stack is led by Georgi. And this 4th one, hopefully we can have Gary basically today officially accepting it and basically taking over this like work stream, so we can, again, I will explain like what are the goals we're envisioning in some, and like what we want to have like achieved from this. Let's go next slide. So the vision that we have for, again, we had basically past, we start from what we had in 2020, present, and now future. Basically what we're envisioning for 2021, like we want to go with this canary deployments. Basically, what are the highlights? What we're doing basically in across the industry with PTP, with, again, what PTP brings, precision time. What again, applications we have, what are the highlights, what are we learning from this? And this is basically on the why. And then on the how side of it, we're looking for, let's say, the open source Grandmaster, again, with a time card, fully an end-to-end solution, having like basically all the bolts and nuts, everything that is needed basically to make this happen. We want to have at least something that is out of the box. If you don't have that much expertise, you just want to use it, you can do that. It's not something that requires you to have like knowledge in depth to basically get it work. And if you have knowledge in depth, you can collaborate and contribute and so on. That's like pretty much everything like we're envisioning for this, and we're putting it there. Like, it is very interesting, like I like to share it here, like that when we reached out across the industry about this idea of open source Grandmaster and so on, we're not taken serious. Doesn't matter even like you represent whatever company. We're like, often it was either like you're not taking serious, or there were conversations like, oh no, we don't want you to do this because like our business model is different and so on. We're like, okay, then what can we do? We have these requirements, right? And the answer was like, yeah, if you want for these requirements something that is open source and so on and so forth, you have to give us like, I don't know, this amount of money, some crazy amount of money, and this amount, like time that was also not so feasible, and wait till we give you something. And is it going to be open source? No, it's going to still be closed source. And we're like, definitely we need to talk in a different language. So what we did is like basically we pulled our sleeves up and we're like, okay, we'll build it ourselves. So we built something, and then once we showed like some prototypes and everything, the whole tone changed. It was like, okay, we want to collaborate on this. How can we help? And then like, okay, we have these blueprints, these standards, like just continue from there. And then all of a sudden everything just cracked open. I'm pretty sure a lot of you guys have more experience in I don't know, in working across industry on things, have experiences. But it was very interesting for me. All of a sudden, the whole thing, all the business justifications basically came in.
And I think
So
this is the power of the community, right? When we put multiple forces into to work in synchronization, then we achieve things faster and
yeah,
and get there with a wider exception. And this is ultimately the goal here with
yeah,
TAP.
exactly. So what one thing that we are really looking forward coming up is like, we want to have a hackathon for like precision timing, and we want it to be supported across the industry. So we can have basically we can set at a certain time where we can have it more like a challenge. Then we have open to public. We can, I love to have academia mainly there because a lot of ideations, and we can have like a competition thing in the end, like that the ideas will get judged, and there will be now like first, second, third, we'll have some prize for them. And during the hackathon, basically people will come up with ideas, and if some implementation, again, more merits to the idea. We end up basically with list of applications, possible applications that they can really take advantage of precision timing. And we can, again, if anyone is interested, please reach out to Kelvin. You can sign up for that, like if you want to be a judge or something for that. And we want to run this as soon as possible. Like, again, we set a nice date for that, and we advertise it everywhere, and we bring people in. I'm very excited on that. Yeah.
Ahmed, I want to add on that, please.
Yes, please.
I think the hackathon would be like the core of collaboration. What we are really want to from you guys is the main call for action is that we want you to promote your ideas. Even if you don't intend to participate, if you have an idea that someone can come and implement it in the hackathon, if someone will find it admiring or worth it, he will implement it. So give us ideas. You can come be mentor. You can come be guides for team. You can introduce it to code ninjas guys in your team. This is their way to find out more about timing service and what can be accelerated. And this is again a very good platform for collaboration and make things shine. We will deliver the state-of-the-art devices and all that's needed, and let's do amazing things.
Yeah. And this was, again, if you don't know, this was Dotan Levy from NVIDIA. Okay, so, and also more importantly, we want to reach the point where we can basically take TAP out of incubation phase. And this is probably a question for Archana. If Archana likes to give us something. Archana is looking for the mute button.
Yeah, yes, I am. Can you hear me?
Yes, loud and clear. Yeah.
Okay, all right. So yes, the idea to move, or the challenges to move this from an incubation phase to a mainline phase requires contributions. So whether it is a contribution for a specification for a given appliance, or whether it is software contributions, or say the Open Grandmaster or whatever, we need at least 2 out there, so that people can then come and start to build on it. So we want to take this from a conceptual phase to something that is tangible for our community to come into our, OCP GitHub or, contribution database and adopt this as, part of their ecosystem moving forward. So that's truly what we're looking for. And of course, adopters are not going to come until they have something to adopt. And so that doesn't just mean software, it sometimes means hardware plus software, or some way to deploy this in their environment. So as
Wonderful.
soon as we
Do you
have that,
have-
we'll go ahead and we can go ahead and, go before the IC and say we're ready.
Do you have any contributions to date, or you truly need to?
Oh, we do. We do have contributions. I think we need to formalize them with the right format and the right set of OCP documents. But the first 2 work streams, so one being the, here you go, the first work streams, the time card and the PTP profile do have drafts in place. They are available on our wiki page. So the Open Compute tab wiki. And these will be the first contribution candidates, Archana.
Perfect. Yeah, and what we mean by approved contributions, Gary, is really it needs to go before our incubation committee, that it is in its final form, that we have, contributors and licensing in place so that we can make it public for our audience to use it without any patent infringement or, that sort of thing. And then what we'll do is the IC will then approve it. It'll get put into our contribution database, and that particular GitHub repo will become public. And we absolutely, at that point in time, want to socialize and broadcast it across all of our communities, right? Across all of our social media, that, hey, this is out there, it's ready, use it, build on it, bring whatever you're building, all your mods back into the fold so that more people can benefit from, your use case and your environment and your learnings. And then it truly becomes a community effort. So that's what we're looking for. So as soon as you're ready to, make this final, work with me and Rajiv. We'll work it all out for you.
Wonderful. Okay, let's go next slide. So again, the first work stream, so as Archana also mentioned, the time card is pretty much at that stage. We have it open to public. You can reach out, either you go to the GitHub repository for OCP and you can find it, or simply just type in timingcard.com and it redirects you exactly there. And everything is open source about the project. And we went through the 2nd iteration, and now we're basically entering the 3rd iteration. A lot of like minor things, all the bugs, it's just a work in progress. Yeah.
This is Rajiv here. Just one. I actually have a couple of comments, but let's talk about this slide. So why do we use this timingcard.com? I mean, it points to the Open Compute URL. So any particular reason for leveraging this?
It's just easier. It's just easier to remember, and then just like have right away, it directs you there.
The only problem with that is when we would like to evangelize our Open Compute websites more than the .com thing, because it looks like more of a private domain. But again, this is a pretty small thing.
It's just a link that is like permanently just like pushing toward there. So, and one thing is like we're thinking like eventually if we want to move it from there inside, like we want to have like more comprehensive about the time card itself, this thing doesn't change. That's why. Rather than just like a long link with like, I don't know, a lot of things. Like eventually
it's a friendly URL.
Say again?
It's a friendly URL.
Yeah, exactly.
Yeah, I mean, yeah, if it is used internally for you guys to just have one master click that takes you everywhere, that's totally okay.
And we have another one that's OCP Tap that takes you basically to the wiki.
And that's ocptab.com.
Yeah, ocptap.com.
Okay, I mean that's okay. I mean if it's being used internally, but you got my point, right?
Yeah.
You know,
We will you know, protect the brand and
Yes.
use it externally with the Open Compute brand. No problem.
Yes, you're spot on. That's what I was trying to look for. So two more things. In your previous slide deck, I did see Canary deployments. What do you mean by Canary deployments? I know it had 3 sub-bulleted points. I didn't understand that.
Yeah. So, you know, we are working, Rajiv, on these principles of how to deploy time appliances, and we are looking for the first use cases to come forward and share with us what have they used, what are the building blocks, what are the learnings, sort of like a feedback loop with real, actual experience in the field. I think some companies, perhaps Facebook, are more willing to talk about their, you know, learnings that way, and some want the encouragement and can have that here in this forum.
Maybe I can articulate it. When we started, a lot of our colleagues at the industry didn't find some of our goal achievable. Frankly, they used those words. So we actually broke, I think we broke a barrier where we will demonstrate in 2021 a deployment of high-scale PDP. And we want to share the information and the lesson learned. There are a lot of lessons learned. And if by any chance there is another company that did it, we are welcoming the collaboration and asking for feedback.
Okay, got it. It makes sense. I understand it now. The other thing is the Open Compute GitHub. I see 2 work streams. I think one is for the Grandmaster, and there is one for the time clock. I believe I saw it like
For the profile, right?
Profile.
Yeah, for the profile. Yes, PDP profile. I remember that right now. I think it doesn't hurt to create, even if the work hasn't been done for the P2P Linux.
So there was there. We took it off because there is some basically there's a process we have to go through for open sourcing and everything. Everything is like forks anyways, but we wanted to have like a little bit more like Georgi basically. Again, this is from Georgi's side. Georgi is going to basically put that one up. But if you want to just have like the folder, I can just open up the folder.
Yes, since we say TBD, but whoever, you know, the users are, when they visit this site, at least they know that what is being planned, even if this hasn't substantially been done, but they understand, you know, that okay, you know, these are the things that they would like.
The fourth one as well. Yeah, we'll put the 4th one also, and we basically make Gary the owner for it.
Exactly. So, and my last comment is, and again, I'm not sure how relevant it is, but since there are not, I think Archana very well mentioned that we need, you know, a couple of contributions in order to, you know, what do you call, upgrade, you know, the status of this project to be more of a mainstream. So the contribution has to be from different companies, not just one company. Just keep that in mind as well, because it makes our case stronger when you guys bring this one up to the IC.
So I'm going to explain that if we go back to the slides. So the time card, it was something that we started, but then you can look here, Aurelia basically adopted the time card, and they have the next Grandmaster right now. Based on the time card, their own spin, they're calling it something card, which is basically a time card, and their new Grandmaster is based on that. And like basically open source, you have like a flavor or pretty much PDP4L that is running the software side. You have the time card, that's a PCI Express card, literally like the same way we showed the blueprint. And the driver for the time card is right now part of Linux mainstream, thanks to Jonathan Lemon. So Jonathan Lemon wrote the driver for it, and we were able to put it in the trunk for to the mainstream Linux. I think 5.6 plus. You have it out of the box. You have a new kernel, you plug the card, you don't need a driver, it's already up. And this is a strong selling point.
Oh, yes,
NVIDIA,
that's brilliant.
yeah, and NVIDIA, the same thing. Like NVIDIA is also, I think Dotan is probably better to talk about. Dotan, would you like to chime in?
Yes, we're going to have we will sample next month the Grandmaster NIC based on the open Grandmaster design, and it will be, I mean, fully featured. All speed, all link speed, all the software is already upstream. It's we are very excited about this, and we are also, there is another vendor that worked for us to create an additional more low-cost version of the timing card. He is not yet willing to unveil because he wants to open up once it's ready. But this concept is very exciting. It's allowed to mix and match the best of everything. So the timing card concept is amazing, and we will have low cost, high cost, more accurate, less accurate, and so on. You can take any NIC that you want. We happen to be the first, but you can take any NIC that you want, and you take open source software, and there you go. You have a Grandmaster.
Yeah. So the time card, I want to emphasize that the time card is much beyond, let's say, I'll say even OCP. The time card is something right now is like we have from the PCIe, you know, like there's a board for it or something. We have 0400 in hex, basically the DID for this card, and then the VID is open. It means any VID can use this DID. So when you plug a time card from your company and you follow this, and everything is in the design, you follow these addresses, the driver will recognize it and you will have it right away showing the basics. Now, if you want to have some extra features because you're selling a more expensive card, you can have an extra driver. So this is pretty much like a VGA card that you plug a VGA card, super fancy VGA card or like a vanilla VGA card, they will all do the basics. They will show you, they will send you the video stream on your monitor. You want to have the extra features, you put your driver and everything comes in. So this is how we're looking at it. And like we're really pushing it more like sound card, video card, time card, like this. And we're thinking much more than, like we're really thinking about like a B2C application for it as well. Like like there are a lot of applications for sure. You can take advantage of time.
Let's try and cover the next work stream. Okay, guys, we have 30 more minutes.
So sure. So the next one, basically, again, the DC profile. If like basically we had like an initial draft posted by Michelle. We had a meeting as well, and one meeting, basically all of those 12 was dedicated for the DC profile. There were about 7 feedbacks from community, basically received about 7 from across the industry. If Michelle is here, it would be great. He can basically shed more light on it.
Yeah, I'm here, Ahmad.
Wonderful.
Yeah, so yeah, we posted the initial draft at the end of November. We kickstarted an activity with a number of community members that are interested in reviewing that initial draft. So far, we have received comments from companies such as NVIDIA, Keysight, Renesas, SideTime, Intel, and I think that's about it. These comments, we're going to resolve these comments, and hopefully we're going to come out with the next version of the draft, which will then be submitted or presented to the OCP incubation project group.
Thanks everyone for jumping in. Starting in December, we already have so much feedback and so much progress. That's great to hear.
Okay, so let's go to the next slide.
I have a question for Michelle.
Yes,
so we provided comments. Are we going to plan a meeting to resolve these comments?
Yes, that is correct. I'll incorporate a lot of these comments, and then we're, those that require to be discussed, we'll discuss that with this, at least with the same, members, and you were part of this. Yeah, probably in the next 2 or 3 weeks. And by the way, anyone else that wants to contribute to the review, now is the time to do so. And just to set the stage, that PTP profile is a specification, is a requirements, document, and basically setting the stage from what you expect from anyone that will, implement certain components in hardware or in software. Thanks.
And
So, Elad, I think Elad made a comment that we are not really doing anything with PTP, although okay, you can use anything else, but it is a PTP profile. So are we going to sync the work of this, of defining this PTP profile with what is going on in working
Hisham,
in
that was my
1588?
Hisham, that was my comment, and all I said is like we are open to explore other things as well. But then the DC PTP profile can be eventually, like right now, the DC PTP profile is right now targeting PTP. But let's say in the future, something else comes up, it will be DC something else profile, something like that.
Yeah, exactly. I understood this, but in terms of PTP, are we? What I was going to ask, are we going to sync our work for defining this profile with what is going on in 1588 working group in IEEE?
So
yes,
for
yes,
example,
yeah, why not?
Example,
Absolutely.
there is
Sure,
work item. There is work item that will be discussed in this group, 1588 group, about failover and multiple grandmasters. And Michelle talk about that in profile definition. Are we going to sync our work with their work?
Absolutely,
we
yeah.
can certainly share, but don't forget that 1588, in the standard itself, defines how other industries want to create a profile for their own use case scenario.
Yes.
So you're totally right that we reference 1588 2008 and 1588 2019 in the profile. So anything that is IEEE does, you technically inherit this as you design a profile. Yeah.
So if there are new ideas that they are discussing in February about multiple grandmasters, are we going to have a position regarding these ideas? Are we going to contribute to them, or we'll just stick with what is in defined in the release spec of 2019?
Right now, the only thing we do, Hisham, is to reference 1588 2008 and 2019. Anything that is done by IEEE that is not normative or part of their standard is generally not visible to the other industries. Yeah.
So what you are saying, Michelle, we will just stick with that, but this does not preclude having this group contribute to the development of 1588 standard.
No, I don't see why not. No.
Okay, okay, that's fine. I want to understand the boundary of the work. Thank you.
Thank you, Hisham.
So
moving on to work stream number 3, this is where we're talking about open timing software stack. Dotan, do you want to share some of your enrichment ideas? Dotan Levy, NVIDIA, still with us?
Looks like he was probably not there. So I can probably just is message there?
Dotan? Okay, Ahmed, go ahead.
Yeah, message. Anyone from Intel? No one? Calling once, twice? Okay, so I'll do it. So basically, right now, PTP4L as
I'm back.
okay, good, great. Go ahead.
Just in time, Dotan.
Yeah, I'm sorry, disconnected. So I think Ahmed pronounced it nicely earlier. We want to give some love to software at this part of the time. And one thing that we definitely want to do is to enrich PTP4L. We want to give it the ability to scale up in a DC scale, which means that we'll have to do some performance improvements, some scalability changes. We want to add the visibility. When you have enormous number of clients, you need some different way to see things, to do the logging, monitoring, and collect statistics. Hopefully, we will be able to support more operating system. I think this is quite challenging bullet, but it's still there, as you know, just to mention that there is a target. And of course, we want to enhance and add more features, basically bring all the things that needed. There are a lot of PTP profiles now defining many different types of timing error, and so on. So we would like to add those features to PTP4L and extend enhance interface and application primitive. So what we actually want to state here that we again promoting a call for action for you guys. If you have any idea or any thought what is missing in the great Linux PTP project, please share with us. We will have some brainstorming on all the topics, and we'll prioritize them, and we'll start to put some brain into that, and muscles, by the way, not only brain. Yeah.
Any insights from the forum?
Do you have anything published about this timing, open timing stacks enhancements to PTP4L?
Can you please repeat the question?
The question is, whatever your group is doing, is it to enhance PTP4L? Is it documented somewhere, like GitHub or Wiki? Or...
So far,
we will. Yeah, that in the next call we will collect all the ideas and specify them.
I think the short answer is no for now, because I mean, you can see in the GitHub there are 2 folders, and that was what Rajiv was saying. So we want to have like basically a third one and then start from there and so on. Again, this has been a little bit the emphasis was less, and the main reason is because just chronologically speaking, you need to have the hardware first to do the software. So the hardware is coming along, like the open source Grandmaster, the time card, and everything. Now you have these things. Now you can basically make these tests. That doesn't mean that we couldn't have done it earlier, but again, the emphasis was on something else. Like we're busy like frying a bigger fish, basically. So
right.
Okay, without further ado, let's go for the next work stream. And so here's the next work stream, and there were some thoughts that we had like initially, like for example, the stratum definition is a little bit cumbersome, and by no means we want to, let's say, add more, let's say, acronyms or like, I don't know, standards or something. However, we were thinking like we want to have something more friendly, let's say, with respect to our industry. Let's say define some classes. Again, these are just like ideas, and define, let's say, different classes for the oscillators, and let's say class 1 is for grandmasters, and then the definitions should be very clear, like as much as possible, like metric SI things, not like ppm or I don't know, like I don't know how phase noise, like you have to consider it, like the integration of it gives you this. No, proper things for holdover. You have this for, and then within, let's say, data center specs, like for temperature and vibration, environmental changes, all these things. Let's say, for example, class A, it's class 1 is, let's say, grandmaster. Class 2 is for boundary clocks. Class 3 is for, let's say, NICs that they are, let's say, like let's say, I don't know, somewhere you have also something for transparent clocks. NICs, they have, let's say, this class, and that's NICs that they need PTP. There's a class 4 for, they're less, like, let's say, sensitive. And then everything has to be like a spectrum. Like you have this accuracy, this sits here. So now when oscillator makers like SiTime, Epson, whoever we have, they have their products, they can basically say this is this class for the OCP product or something. And with that comes an entire, let's say, I don't know, certification, everything, which I think OCP is great in that. So this stream basically is going to focus mainly on that. And I like to have Gary, which basically Gary accepted volunteering basically to lead this group, to have some words on that. Gary?
Yeah, I think we have in one of the earlier sessions, we talked about some of the inaccuracies that lead to some of the limitations of oscillators that lead to timing inaccuracies in the system. And I think we can use that as a starting point to use that model and think about the characteristics of the oscillators to try to quantify exactly the parameters that we would want to specify as part of these different classes for, as you were saying, the boundary clock, the grandmaster, and so on. So I think that'd be a great start.
And
Thank you
on
for
top of,
volunteering, Gary.
Oh, you're very welcome. I'm honored. Thank you.
and on top of that, like for example, last year we had the presentation from John Kitching about like chip scale atomic clocks. So we also, like, time to time we have these presentations of, like, I don't know, something with like the technology, the physics behind it and so on. Like again, oscillators, you're really touching now physics. So it's pretty interesting. So that doesn't exclude, like, as I said, like the science aspect of these things. So let's, anything else you want to add, Gary? Gary is from SI Time, by the way.
No, I think you know, this OCP, I'm still quite new to it, so I'm very interested to see how the development works, and yeah, it should be exciting.
Wonderful. Thank you, Gary. Okay, so go next. Okay, so we have some upcoming things, like we were still like talking about which one should come up first and so on. Again, one will be like for the enriching PTP4L. So I think Hisham will be happy to see like all this, what are we intending. And Hisham, it's not a monologue, it's a dialogue. I want you to also basically work with Elad and Dotan to add more, like whatever you think it's needed, because your comments are always appreciated. And again, toward basically how we can use PTP4L for like scaling and the functionalities and so on. We're gonna have soon a presentation from one of the GNSS vendors to talk about like what is under the hood. We're just getting the PPS pulse and we're happy with it, but definitely there is a lot that at least the signal travels across the globe, goes to orbit, comes back, you know. So we want to know a little bit more about that, just like so we can appreciate it more. When, I don't know, 12 nanoseconds becomes 20 nanoseconds, we don't go crazy, and then we appreciate how much like things are happening. And Dotan mentioned so like there is some interest from the automotive market. Dotan, you want to chime in a little bit on that?
I think the ton had to drop, but yeah, we are sensing that that demand growing, and there is considerations here which do fall into the same category as data center, and I think it's good to view a snapshot of what's going on in this market and the adjacencies that come along with that.
Yeah, wonderful. And we have also, as I said, like in the beginning, I mentioned like with PTP is some right now, like basically hot topic. Everyone's like using it again for precision timing and so on. But there are alternatives. Alternatives again, there are a lot of like, let's say, there's always like there's no free lunch. There's always something like may like do some compromises or so on. All things need to be tested, but that doesn't mean there is no room for like new things. Like I have no doubt, the same way PTP came, NTP, like as a successor for NTP, there will be a successor for NTP. What is it right now? We don't know. To be determined, we can find out. So one of those like candidates can be the Huygens. So Huygens is from Stanford, introduced by Professor Balaji's team. And Hisham, would you like to add some words around that?
Yeah, so I have a few comments. Of course, taking advantage of the time synchronization mechanisms that Balaji and his group used it primarily for FanTech is something definitely very useful. And Eugene really is one of the main guys who are working with Balaji, one of his students, so he's perfect to do this. But again, he's using the time synchronization that is developed by Stanford. This is not really BTB, which is more accurate. Based on what Balaji told me, it is more accurate than BTB.
So
We great to see the
maybe
different implementation.
maybe we can basically introduce, like, invite Balaji to give
Oh
a
yeah,
presentation.
that would be great. Yeah.
Would you like to take over that part as a task?
I mentioned to Balaji that Facebook has this project. I think it is better to come from you.
No, we already have like a time slot, let's say, for it. We just want to have
Good.
yeah. Would you please coordinate with Kelvin on that, and then have a date set, so we can have Balaji here. The community will
Yes.
definitely enjoy.
Let me work with Kelvin on this. I have one question maybe for you, Ahmed, and for Elad. Two questions. First one has to do with new topics, like the working group in IEEE 1588 working groups. They are working on security for BTB, and the only things they have right now, as you all know, is key exchange and things like this. So, but they are looking for the industry to help them to define complete BTB profile for security, and they envision this to happen in 2 years. But they are looking really for Facebook, for NVIDIA, for all these groups, all these companies involved in this project, to give them requirements regarding this profile, which is very important.
Yeah.
The one thing to keep in mind is that, according to a discussion I had with the chair of this group, for some of those security requirements, we might need boundary clock, where the current profile, the initial profile defined by Michel, he would like to see only transparent code. He doesn't preclude having boundary clock. Michel doesn't preclude it, but
the reason for that, first of all, Hisham, what you're bringing up can be well number 6. You see there? Present your own.
yes,
So
exactly.
always open to. We are always
That's
open to this.
we are open,
You're a big contributor for this, so you always look forward for that. The second thing, just like try to emphasize, because this is brought up, like, so the profile that Michel has that is only transparent clocks, the reason for that is that's the intermediate phase that most likely every other, let's say, industry, let's say other company, let's say in our industry, in Datacom, may face, because boundary clocks are much more complex than transparent clocks, as everyone knows, because again, transparent clocks, just you can enable like the one step, the correction field thing, like basically just with the ASIC, packet comes in, gets recognized, it gets stamped, like the correction field goes forward. Boundary clock, you have to terminate packets that they come to you. So now guess what? The switch is having an IP address. And now, and because especially we're talking about like unicast, and now the switch has to initiate things. So this requires, like most of, like, let's say in our industry, the switches are basically just pipes funneling the packets going around, you know, and now there's no IP address for them in that data plane. Like they just take this, send it there, and then it's defined like where things should go. But now packets get sent through the network to that boundary clock. The boundary clock has an IP, the switch is basically having an IP address. So this takes time. It takes, again, there is again, which there's absolutely no like roadblock, like there is no deal breaker here. It just needs time for, let's say, for the operating systems that we're running basically in the switches to be more developed and capable to do things like that. And that's why we're just making this ramping. We're giving all the heavy load, basically all the heavy lifting to the grandmaster to talk to everything, like basically going through the, like to the transparent clocks. And then we also defined a backup plan, like basically if the grandmaster gets choked by so many packets that it needs to send around, we defined this thing called designated master clock. Basically, the job that the switch is going to have in the boundary clock, that basically there is the packets they get there, and then they get basically disseminated further to the other nodes. This will be taken care by one of the ordinary clocks. So the grandmaster, instead of talking to, let's say, all 50 or 100 or whatever, 200 machines in one rack, it talks to only one rack. It synchronizes only one rack. So right away, the workload on the grandmaster gets divided by 200. Then that machine will basically, again, it's unicast. You can do all these things. All you require is like from every port, every direction, transparent clock capabilities there. Then from that port, in that rack, basically from that machine, from that rack, all the other machines will basically check with this machine. So this, we defined it also as a designated master clock, DMC. And again, it's a backup line. It's not ideal, it's messy, whatever, but then it's a solution, you know, like you can also round robin it. It's not the same machine. You can have always two. Again, you can figure out like what's going on. Okay, so the fifth one we're looking forward is by Mark Weiss and forgot his colleague from OPTN, which is a company that basically provides like precision timing via like fiber optic, basically to your doorstep as a like accurate time as a service, basically. So Michelle, you want to add a little bit to that? Monty and Mark Weiss.
No, I think you've covered everything, Madia, about having them to come and present to the community, yeah, what they are working on as part of that time.
Is synchronizing database is the only application we are considering, at least in the first phase?
I would say it's one of them, and we're happy to hear about more applications that people are putting to test. This is again where we ask for the community here to share the use cases and how timing has helped with improving the application performance. This is what we're after, right? So distributed databases is something that comes to mind. I'm sure there are plenty more. So the automotive market has different ones. But when we look at the data center, the question is open here to the forum as what are the applications to take forward.
So when you talk about automotive, I don't think you talk about the network in the car. You talk about maybe edge computing, the network in the edge, the data center at the edge. And if this is what you are considering, then you should also consider edge computing for financial technologies.
Yeah, absolutely. Absolutely. That was
for any edge computing application. I'm sure you know tons of them.
Yeah. And do we have another slide?
I think this is it.
Yeah, that was it. Yeah.
Yep. So altogether, we have a lot of exciting things to do. I think we just started.
So Elad,
yeah.
This is Archana. If I could just have 1 minute. The only thing I was going to say is our next big OCP event is targeted for, fall of 2021, just given the COVID environment. So our global summit is now November 9th and 10th in 2021. So between now in January and November, we really don't have any major events planned, primarily because I think everyone's getting conference fatigue, right? We're just attending one conference after another, and it's almost, we wanted to give our teams a little bit of a break between November and the next conference. However, having said that, you all have so much exciting stuff going on that I don't know if we want to wait until November in order to let the community, the broader community, know of all the good work that's doing, right? You want to kind of have some sort of a progress marker in the middle. So some of the other project communities are looking at doing standalone half-day workshops in the March, April, May timeframe. And it's just like a interim checkpoint It's a half a day workshop. They come in and it's going to be more on GoToMeeting. It's not going to be, it's going to be a little bit more casual, but it allows you to not have conflict with any other community. So you can have a broader audience. B, it's a half a day, so it's not like a full day of, back to back to back week-long events, right? And it also gives you the opportunity to broadcast the progress that you have made since Tech Week in November. So just something to think about as you guys plan your next couple of months. If you wanted to do like a half a day TAP workshop, I think that would be actually kind of cool because you guys are making some really good progress, and maybe that we can use as a way to launch some of the final contributions that, the two or three contributions in their final form to the public.
Yeah, absolutely. So this is a good idea. I think that, we need realizing the work streams and the hackathon. So I think we are reaching some gravity here, and probably in this quarter we'll be able to to plan the launch of those and probably summarize it all in a workshop type of event and share that with the broader community. I think it's a great idea, and we can use your help here to help plan that and put it into to execution. I love the idea.
Okay, so just let me know. It's nothing to do now, but as you guys think about it and get closer, just keep me posted. Just to give you an idea, to socialize this properly, we probably need about a good 2 months to 2.5 months. And so, if you're looking at something in the April timeframe, we should probably start looking at it in February. In February, right? Just so that we could put a small agenda together, get a time frame nailed down, a date nailed down, and then you can keep working on the agenda up until you get to that event.
Cool.
Archana, good that we are on this slide. You can see the word highlighted in green. So would you like to help us with that? We want to have it, let's say, somewhere, I don't know, like again, TBD. Like I prefer to have it right after the exams and everything for university, because I want to target university as much as possible on this. So
right.
If you'd like to help us with socializing it, make it actually an OCP event, And,
absolutely. Yep. So you guys tell me how long, is it a half a day hackathon? Is it a full day hackathon?
It's a two-day hackathon.
2 day. Okay. All right.
And then
yeah, just
if you look at NASA Space App Challenges, I want to use it basically something similar to that, like where first day, basically their ideas and everything and so on. And then you can team up with some mentors and so on and go forward. And then toward the end of the second day, you basically have the presentations, and then there will be some judging, and then you basically have winners.
Okay. So having said that, let me know when, again, you're targeting. We need to take a look at, I can tell you what the Berkeley schedule looks like because my daughter goes there. But if you could let me know about some of the other schedules, it's usually right before spring break, and it varies greatly depending on the university, I think. But if you could let me know, that would be great. And then we could plan it accordingly. But yeah, I think that's a fantastic idea. And I can also socialize it with our Future Technology Symposium audience, which is primarily all academics and, research labs as well.
Great.
Okay, wonderful.
Cool.
I think we hit the time limit. So we've covered a lot today and lots more this year to do. Thank you, everyone. We'll send the agenda for the next meeting ahead via the email distribution list.
Thank you so much, everyone.
Okay. Bye, everyone.
Bye.
Thank you.
Thank you.
Have a great week. Bye.
Bye.